Welcome to the second part of our journey into the Kalman filter. In this section, we are going to expand the one-dimensional Kalman filter into multiple dimensions. Now, this section is also more mathematically demanding than the previous ones, but in my opinion, it is also much more interesting. When we move from 1D to ND, or from one dimension to n dimensions, we don't just add equations, but we use a different writing style, a matrix notation. So, what is the toolbox we need for this section? The first is kinematics, the part of physics that describe moving objects. More than any other thing, the Kalman filter describes objects that move in the real world. To describe an object moving in the real world, we will need to know the basics of kinematics. I'm assuming that you more or less remember this from high school, and even if you don't worry. We will explain and review the equations of the motion in the current section. The second thing that we are going to talk about is multivariate Gaussian distribution. This is especially interesting and important because herein lies the strength of the Kalman filter. Sometimes when we work with multiple variables, then knowledge of one variable gives us information about another variable. The best example is position and velocity. If I know the velocity, I can say something regarding the position, and vice versa. If I know the position, I can say something regarding the velocity. The correlation between the variables is expressed mathematically in what we call the variance-covariance matrix, which we will also cover in this chapter. And as always, we will do this step by step. And in the end, you will know how to program the Kalman filter from beginning to end using Python. Good luck!